You ever think about how your computer sends a file to just one specific printer on your network without bugging every other device? It's not magic, but it's pretty close. It's all thanks to a really simple but brilliant system inside every network switch. So today, let's dive deep and explore the switch's brain, the MAC address table.
Right, so this is the core problem we're trying to solve. I mean, imagine the chaos if every single message was just broadcast to everyone. Our networks would just grind to a halt. The solution is this clever little directory that lets a switch be an intelligent traffic cop, and that's exactly what we're going to unpack today.
All right, so here's our game plan. First, we'll look at the unique ID that every single device has. Then, we'll check out the smart directory the switch builds using those IDs. After that, we'll see how the switch actually learns all this stuff, talk about the different kinds of entries it keeps, and finally, we'll look at how network admins can get in there and manage the whole thing.
So before we can really get our heads around the directory itself, we need to understand what's in it. And that all starts with something called the MAC address. You can think of it like a permanent, unchangeable fingerprint for every network device on the entire planet.
The main thing to get here is that this is a hardware address. It's not software. It is literally burned into the network card when it's made. It works at a really fundamental layer of the network, what engineers call Layer 2, which is all about how devices talk directly to each other when they're on the same local network.
Now, fair warning, you're going to hear a whole bunch of different names for this. Hardware address, physical address, burned-in address. They all mean the exact same thing, the MAC address. Just knowing that these are all synonyms will save you a ton of confusion down the line.
So how in the world is every single MAC address unique? Well, it's because of this really clever two-part system. The first half of the address is basically a code for the manufacturer. It tells you who made it, like Cisco or Apple. The second half is a unique serial number that the company assigns. That combination guarantees that no two devices ever roll off the assembly line with the same MAC address. Pretty smart.
Okay, so now we get the unique fingerprint. Let's see how the switch actually uses it. The MAC address table is basically its smart directory. Think of it like a mail sorter in a huge office building. It doesn't need to guess. It knows exactly which mail slot, or in our case, which physical port, every single person or device is connected to. And here it is. This is what that brain looks like. It's just a simple table. It maps a device's unique MAC address to the physical port it's plugged into. We'll get to what that type column means in just a bit, but the goal is super simple. When a message shows up for AA1111, the switch just glances at this table and knows, I only need to send this out a port ET0/0. No shouting required.
You might also hear this called a CAM table. CAM stands for Content Addressable Memory, which is a special, super fast kind of memory. It lets the switch look up an address almost instantly. It's the secret sauce that makes modern switches so incredibly fast and efficient.
Okay, so how does this table even get built in the first place? This, to me, is the coolest part. When you first plug in a switch, that MAC address table is totally empty. It knows nothing. So how does it go from being completely ignorant to being this intelligent traffic director? Well, it learns by listening.
All right, let's walk through it. First, a computer sends out a message. The switch gets it, but it looks at its table and has no idea where the destination is. So what does it do? It does the only thing it can. It floods that message out of every single port except the one it came from. It's basically shouting to everyone. Then, the correct device gets the message and sends a reply. Now here's the magic moment. When that reply comes back, the switch is listening. It looks at the source of that reply and it immediately makes a note. Okay, that device is on that port. It does the same thing for the original sender. Just from that one conversation, the switch has already started building its directory. Next time, it won't have to shout.
So that automatic learning process we just went over, that's how dynamic entries get created. But that's not the only way. Network admins can actually step in and create manual or static entries to have a little more control.
And here's the main difference. Dynamic addresses are the default. The switch learns them on its own, and, this is key, they age out and get deleted if a device goes quiet for a while. Static addresses, on the other hand, are put there by a human. They never expire, and they even stick around if the switch gets rebooted. You'd probably do this for a super important server, just to make sure the switch never, ever forgets where it is.
Speaking of aging out, what's the deal with that? Well, on a typical Cisco switch, the default aging time is 300 seconds, so 5 minutes.
What this means is if the switch doesn't hear a peep from a device for 5 full minutes, it'll just remove its entry from the table. It helps keep things tidy. If that device talks again, no big deal. The switch will just relearn its location instantly.
And that really is the whole point of the timer. Networks change all the time. People unplug laptops, move computers, turn things off. The aging timer makes sure the MAC address table doesn't get clogged up with old, useless information. It's basically a self-cleaning oven for the switch's brain, keeping it running nice and efficiently.
All right, so if this table is the switch's brain, how do network administrators actually peek inside and control what it's doing? Well, they've got a whole set of tools, usually in a command line, to see and manage everything.
For any network admin, this is your bread and butter. It's the command that gives you a direct window into the switch's brain. You can pull up the entire live directory and see exactly which device is connected to which port at that very moment. It's absolutely essential for troubleshooting.
Of course, a switch doesn't have infinite memory, so another important thing to check is just how full that table is getting. This command tells you how many addresses the switch has learned, which helps you plan for network growth and make sure the switch isn't getting overloaded. Remember that 5-minute aging time? Well, it's not set in stone. Admins can change it. On a really stable network with servers that are always on, you might increase it. But in a place like a busy coffee shop with laptops coming and going constantly, you might make it much shorter to keep that table super fresh. And finally, for those really critical devices, an admin can manually create that static, permanent entry we talked about. This is like carving it into stone. It tells the switch, hey, this device will always be on this port. Don't you forget it. It's a great tool for beefing up security and stability.
So when you boil it all down, that's the big takeaway here. Way back when, we had devices called hubs that were just dumb repeaters. They heard something on one port and just shouted it out to everyone else. The MAC address table is the piece of intelligence that turns a switch into a smart traffic director, allowing it to learn the layout of the network and send data precisely where it needs to go. That's why our networks are so fast today.
And that kind of leaves us with one final, interesting question. We've just spent all this time talking about how MAC addresses are these perfect, permanent, unique IDs for devices on a local network. So why do we even have this whole other system of IP addresses? What's the point? Well, that's a great question, and the answer takes us from our local network out to the rest of the world.